First, we loose the valve nut, and beside that, we remove the valve to explode the brake assembly. Using 14 mm spanner to loose the brake hose nut. Beside that, we use a wrench thread to collect the leftover brake fluid when disconnecting the brake hose. And use 17 mm bolt and air drill to remove the caliper bolt. And remove both the inboard and outboard brake pads carefully.
For the inspection, first we check the surface condition of the disc brake and the condition of the brake assembly part.
For remove the piston in the caliper body, first we need to remove the bleeder screw by using 8 mm spanner. After that, using the air blow gun and pump the air in the bleeder hose, and the piston will come out.
The piston is in a good condition. Piston boots is in poor condition. The rubber on it has torn and cracked. The hole in the cylinder is in poor condition because it has rust on the piston hole. Measuring brake pad thickness for inboard and outboard. We measure 4 points for each pad. Use a high gauge to measure the surface of the disc brake, as the results show that the surface of the disc brake is indeed uneven as shown in it. Next, measure the thickness of the disc at each of 6 different points. The first point is 23.12, the second one is 23.17, the third point is 23.41, the fourth point is 23.09, the fifth one is 23.56, the sixth one is 23.27.
Then chalk the disc brake surface and rub it with the brake shoe.
There are factors that cause this is such an uneven air pressure or low viscosity. The pin lock is in good condition, which is straight and not bent.
For refit this brake assembly, first one, set the caliper into the frame. After that, insert both inboard and outboard pad into the caliper. Assemble the brake fluid cable on the brake assembly and tighten the nut. Insert the sliding pin. Assemble back the tire and tighten the nut. Then all the procedure for this brake lap are finished.
For the first part of our discussion, we will talk about the condition of the black pad. And during our inspection, both the outboard and the inboard pad and measurement between 8 to 9 mm in thickness. So which is still above the minimum limit of 3 mm. This means the pads are still in good working condition and do not need to replacement yet. And the pad surface is still smooth and with not crack or metal contact, so the braking performance remain good. However, the surface of the pad are show uneven wear with the certain area worn down close to the backing plate as shown in the image. This indicated uneven pressure distribution between the pad and rotor, just like we see when we remove the piston board has already broken. So this will cause the pressure distribution, uneven pressure distribution. So likely due to the slight rotor run out or previous caliper movement issue. Although the thickness is acceptable, it is recommended to replace both pads to restore the smooth and even the braking contact, prevent the variation or brake noise.
For discussion, question number 2. Two causes of rotor disc thickness variation are: first one, the presence of rust or corrosion on the rotor surface. Second one is the uneven tightening of the wear nut which can cause rotor distortion. For the correct repair procedure is: first, clean the rotor and hub surface thoroughly to remove any dirt or rust. Next, measure the rotor thickness at several points using a micrometer. If the thickness variation is found, the rotor should be resurfaced or replaced if it below the minimum limit. Finally, reinstall the rotor and ensure all the wheel nuts are tightened evenly using the torque range according to the manufacturer specification.
So for the question 3, the answer is round out measurement data show how much the brake disc move sideways while it rotates, and it helps check if the disc surface is flat and correctly aligned. And the measurement is taken using a height gauge, which record the disc movement as it turns. In this lab, the results show a counterclockwise reading, meaning the disc slightly move in the opposite direction of rotation. This indicates a small amount of unevenness or wobble on the disc surface. If the reading difference is more than 0.05, the disc may be warped or not properly installed, which can lead to vibration, uneven pad wear or noise. So overall, the run out measurement help ensure the disc brake operates smoothly and safely.
During the guide pin or lock pin straightness check, I found that the pins are in the good conditions, straight, smooth and free from any bends or corrosions. This is important because if the pins were not straight, the caliper would not move evenly, which could cause uneven brake pad wear, brake drag or reduce brake efficiency. It might also lead to vibration, noise or overheating of the brake component. Since the lock pin in good conditions, the caliper can move smoothly, ensuring to this brake system operate safely and effectively.
In conclusion, this laboratory section has give us a clear understanding of how to inspect to remove and refit a disc brake assembly safely and effectively. During the inspection, both the outboard and the inboard brake pads were measured to have a thickness between 8 to 9 millimeter, and which is still above the service limit. And however, we noticed the slight uneven wear on the pad surface, showing that the braking pressure was not completely even. For the run-out measurement recorded between 0 and negative 0.2 millimeter, which is slightly higher than the recommended limit of the 0.05 millimeter. This indicates a minor disc surface unevenness that may cause the variation or noise is not corrected. For the guide and the lock pin, we rolled smooth on a flat surface and confirming they are straight and in good condition. Therefore, the uneven pad wear was mainly due to the rotor run out rather than the caliper pin issue. So throughout the servicing process, we followed proper safety and environment practice by using a plate to organize truth and the tray to correct the leftover braking fluids. So this ensured a clean, surface, and safe and environmentally responsible working area. So overall, the disc brake system was found to be in a good working condition and with minor imperfection that can be corrected through the rotor resurfacing of replacement. So this lab changed our practical understanding of brake system diagnostics and component inspection and safe servicing technique, and which is essential for ensure vehicles safety and performance.